All right, this is for Algebra 1, Lesson 15, and this deals with the elimination method for solving two equations. Now, if you would graph, these are two nice lines, that's why it's called linear equations, and they would intersect somewhere, and we're trying to find that point of intersection without graphing. So what you want to do is you always want to line up all your x's and y's, get them on one side. Notice I have my equals lined up. So notice if I add these two together, some textbooks will call this the addition method. But here's the deal, you want to look ahead and notice if I add straight down how my y's will be eliminated, because 2y minus 2y is 0. So these are eliminated. That's the whole goal. So this one's actually rather nice. So x plus 5x is 6x. 8 plus 4 is 12. So you can see here that x would be 2. Okay, so then, just like then the substitution method, you're going to come, pick any equation you want, and where you see an x, you're going to plug in 2. So I'm going to pick this one just because it looks nicer. So I'm going to copy my equation down again. Where I see an x, I'm going to substitute in a 2. All right, get the y by itself. So I'm going to take this 2 to the other side. It's a positive 2, so I'm going to have to move it over here by subtracting 2. So you get what? 2y equals 6. Divide both sides by 2. So you should get y equals 3. So this is your point. Your x value is 2. Your y value is 3. So you want to be sure and write it as an ordered pair. And that is the point that those two lines would intersect. Okay, so that was a pretty nice one. Here's another one. This one is not quite as nice because if I would add straight down, this is going to be a 4x. If I would add straight down, I would get a 2y. So there's several things you can do. What I would probably do, what I think would be easiest, since this is a positive 2x, I really wish this was a negative 2x. So I can do that. I can just turn that if I want. I can make it a negative 2x. I had to get my lid off my marker just a minute. But if I decide to change the sign of this 1, I have to change the sign of everything. So notice I'm just going through and I'm going to change the sign of everything. So you have to be consistent. So now when I add these together, my x's are gone. They are eliminated. So I have 3y plus 1y, which is 4y. 7 plus a negative 3 is 4. So divide both sides by 4. So here you can see that y is 1. All right. That's the elimination from here on out. It's just like the substitution method. Pick any equation you want, and you're going to plug in y. So I'm going to pick this one. It's probably not the easiest one, but I just want to see, I want to show you that this works for any equation. So let's see here. That's a 2x plus 3, but where I see a y, I'm going to put in a 1. Okay, so this is a 2x. Notice this is 3, so I'm going to subtract 3 from both sides. So I get 2x, oh my gosh, that scared me. My dogs just knocked something over. The dogs. So you get x equals 2. That's funny. So my ordered pair is going to be 2, 1. Make sure that you always put it with the x value first and then the y. Okay? All right. Let's look at this one. Now this one's a little different. Again, if you would add straight down, you're going to have to look ahead and notice that nothing cancels or is eliminated. So what I notice here, though, it doesn't really matter, but I want to try to keep this as simple as possible. Since this is a positive 4, man, I wish that was a negative 4. But I can make it a negative 4 if I multiply this entire top equation by 4. Okay, so I'm going to do that. 4 times 2x is 8x. 4 times a negative y is negative 4y. And 4 times 13 is what, 52? 4, 5, yeah, I want to make sure I got that right. So I'm going to take that other equation that I originally had, this one right here, and I'm just copying it right below it. Okay, so notice right here, if I add straight down, I'm going to get 11x. My y's are eliminated or canceled, and 52 plus 3 is 55. Divide both sides by 11. So x is going to be 5. Yay! Okay, so come back up here, pick an equation. It doesn't matter which one. Let's just stick with this first one, and I'm going to copy it back down here. So what did it say? 2x minus y equals 13. Since x is 5, where I see that x, I'm going to substitute in a 5. So I'm going to say, okay, that's 2 times 5. That's going to give me 10. And I notice there's a lot of these in your book like this. If you move this 10 to the other side, notice this is a positive 10, so you have to subtract 10 from both sides. And this isn't any old y, it's a negative y. 13 minus 10 is 3, but you don't want to solve for a negative y, you want to solve for a positive y. So if you change the sign of this one, you have to change the sign of the other one as well. So y is going to be negative 3. So, what is your final answer? What's that point of intersection? Notice x is 5 and y is negative 3. So you want to make sure you're at x first and then the y. So that would be the point where those two lines intersect. Okay, let's do one last one right here. This is 15D number 2. It looks just like this in your book, except not as pretty and green. So notice I'm just going to line it up. I wish they would line it up for you in the book. But they have a 4y, sorry, had to peek at something, minus x equals 5. Okay, again, notice that nothing eliminates just from the get-go. This would give me 12. This definitely doesn't get eliminated. You just want to find the easiest thing to do. Usually there's more than one way you could do it. Since this is a positive 2, I really wish that was a negative 2. I can change that just by multiplying this entire equation by 2. So let me get me a different color going here. So what I'm going to do is I'm going to take this entire equation and multiply it by 2. Because 2 times 4y gives me 8y. 2 times x is 2x. 2 times 5 is 10. So you can do anything you want to any of these equations as long as you do the same thing to everything in that equation. All right, let's write the other one just right below it. So we're going to get a 3y plus 2x equals 12. Now you can see that when I add straight down, 8y plus 3y is what, 11y? And 10 plus 12 is 22. If you divide both sides by 11, they must like 11 today, you can see that y is 2. Okay, go back up here, pick any equation you want so that you can solve for x. I'm going to just pick this one. Why not? So I'm going to copy it down here. It says 4y minus x equals 5. So I'm going to copy that down here. 4y minus x equals 5. But since y is 2, where I see the y, I'm going to put in a 2. Okay, so what does that give me? 8 minus x equals 5. I'm going to subtract 8 from both sides. Notice this is a positive 8. Right here, if you don't see anything, it's positive. So I need to do the opposite and subtract 8. So I've got negative x equals a negative 3. But again, I don't want a negative variable. I want a positive variable. So if I change the sign of this one, I have to change the sign of the other one. So you're going to get x is 3. So my point is 3, 2. And you have to come back down here and rewrite that. So there's the point of intersection. So hopefully that will help you.